This is my intermediate algebra course. Today we're going to continue to learn more complicated logarithmic equations. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. If you don't want to access your files, you can take a screenshot of these exponent rules and logarithm properties, but it's probably best to take a picture with your phone. You're going to need those as we go along today. Today we're going to focus on problems that require us to solve quadratic equations. And there's two objectives of this class. Number one, to continue to learn fluency with logarithms. But number two, we're going to, as I said, review quadratic equations. So let's get started. In order to solve this equation, we have to combine these logarithms using logarithm property 5. Again, if you have a picture of the logarithm properties and the exponent rule on your phone, you can look back at logarithm property 5 up there. When you're adding logarithms, you can just change to one logarithm and multiply what's inside them. So now we're going to use the distributive property. X times x is x squared. X times -5 is -5x. So we've simplified this logarithmic equation as much as we can, and there's nothing left to do except convert to an exponential equation. So remember, the base is that little number there in blue. The exponent is whatever the logarithm is equal to. That's 2. And what's in the log function goes on the other side of the equation. 6 squared is 36. And at this point, we're stuck. We don't know what to do. How do we solve this equation? Well, we can't solve it unless we recognize that it's a quadratic equation. Quadratic equations require special methods to solve. And so we need to use those methods. And it's also important to understand that we can't really do anything with this quadratic equation until we put it in standard form. So in order to put it in standard form, I'm going to subtract 36 from both sides. And now it's in standard form. It probably looks a lot more familiar. Now, there's multiple ways to solve quadratic equations. We can use the quadratic formula, we can complete the square, and we can factor. Now remember, you never want to complete the square unless your teacher forces you to, because that method is long and tedious. And you always want to try to use the factoring method if you can, because factoring is something you're going to need to practice. So we have no coefficient on the x squared term, so we can simply ask what two numbers multiply to -36 and add up to -5. What are two numbers that multiply to -36 and add up to -5? If you said -9 and +4, you're correct. So what we did is we changed this expression, we changed the form to this. And what that does is it allows us to see what the solutions are. X can be 9 or x can be -4. Because if you plug in 9, you get 0 here, and 0 times something is 0, so that equation works. Plug in -4 plus 4 is 0, 0 times something is 0. Alright, now it's important to understand that sometimes you're going to have extraneous solutions. That means a solution where you plug it back into the equation and it doesn't work. Something goes wrong. This -4 here, if you plug it into this logarithm, you see it makes a negative inside that logarithm. You're not allowed to have a negative number there. So x equals -4 is not a solution. Now, please understand that your solutions can be negative if you plug them in and you get a positive after performing operations. But in this case, obviously, if you plug in a negative, your resulting number in that logarithm is obviously going to be negative. So that doesn't work. Now, if we plug in 9 up here, 9 minus 5 is 4, that's positive, and plugging in 9 here, that doesn't produce any kind of negative in the log, so 9 is going to be a solution. So negative 4 is an extraneous solution, 9 is the actual solution. So let's try one more of these before you try one on your own. Alright, so we're going to use logarithm property 5 again to combine those logarithms. Now we're going to use distribution, the distributive property. Y times y is y squared, and y times 7 is 7y. And now we've simplified the logarithmic equation as much as we can, so there's nothing left to do other than convert to an exponential equation. Remember, this little number here is the base, and whatever the logarithm is equal to, that's the exponent. And now 2 to the third power, that's 8. And now, once again, it's very important to understand that this is a quadratic equation. How do we know it's a quadratic equation? Well, because we have a variable squared, a variable that's not squared, and we have a number that has no variable. Once you recognize it as a quadratic equation, you must convert to standard form, or else we cannot solve. So we're going to convert to standard form, and notice that I put everything on the right side of the equation because I want to keep the coefficient of y squared positive. So now we're going to use the factoring method because this is an expression that just happens to be factorable. So what two numbers multiply to -8 and add up to 7? What are two numbers that multiply to -8 and add up to 7? What do you think? If you said positive 8 and -1, you're correct. So what that tells us is that y can be -8 or y can be positive 1. But if you plug in -8 up into this logarithm, we have a negative in the logarithm. So that's not going to be a solution. That's an extraneous solution. So we say not equal to -8. If you plug in 1 into either of these logarithms, you don't get a negative. So that's going to be a solution. So I want you to take a picture of these two pages with your phone or take a screenshot. And I want you to use number 1 and 2 to help you do number 3. Now remember, you're going to have to solve a quadratic equation when you're doing this problem. And start by using logarithm property 5. So go ahead and try number 3, and when you come back, we'll do it together. Alright, we're back. So we're going to use logarithm property 5 to combine those logarithms. And now we're going to use the distributive property. X times x is x squared, x times 2 is 2x. And we have nothing to do at this point except convert to an exponential equation. Remember, the base is always that small number next to the log. The exponent is what the logarithm is equal to. And whatever's in the log function goes on the other side. But we're going to have to use an exponent rule here. That's exponent rule number 6. Anything raised to the first power is just whatever that number is. And now we have to recognize this as a quadratic equation and put it in standard form. So I'm going to subtract 3 from both sides. Now it's in standard form. And now we can solve by factoring. What two numbers multiply to negative 3 and add up to 2? What are two numbers that multiply to negative 3 and they add up to 2? Well, that's going to be positive 3 and negative 1. All right, so changing the expression to that form tells us that x can be negative 3 or x can be positive 1. But remember, we have to check our solutions. If you plug in negative 3 up here, you see we have a negative in the logarithm. That's not allowed. But if you plug in positive 1 into either of these logarithms, you see that we're not going to get a negative in any of these blues. After you perform operations, that is, you don't want negatives. What I mean by this is you plug in a negative, and after all the operations are performed in those blue parts, your resulting number is a negative. That's not allowed. Okay, so x equals negative 3 is not a solution. X equals 1 is the solution. So if you got those answers, good job. So I want you to try number 4, and when you come back, we'll do it together. All right, we're back. So I'm going to use logarithm property 5 to combine the logarithms. And then we're going to distribute using the distributive property. B times b is b squared, b times negative 12 is negative 12b. And now we have nothing to do other than convert to an exponential equation. And 4 to the third power, I'm sorry I gave you such a big number there, but that's 64. And this is a quadratic equation. We have to recognize it as a quadratic equation and then convert to standard form. So to convert to standard form, we're going to put everything on the right side of the equation. And why are we putting it on the right side? Well, we want the coefficient of the b squared term to be positive. Now, if you prefer, you can flip around the equation so it looks like that. That's the same equation, but I want to reduce confusion, so I'm just going to keep it like that. And so now you may have noticed that this expression is a little bit more difficult to factor, but we can still do it. There's a lot of different options for 64, but 8 times 8 doesn't work, or negative 8 times positive 8 doesn't work, that is. Because if you add those up, you get 0, not negative 12. Let's see, 2 times 32 doesn't work, 1 times 64 doesn't work. There's so many different options. But it looks like it's going to be 4 times 16. And obviously one has to be negative, the other has to be positive. 4 times negative 16 is negative 64, and 4 plus negative 16 is negative 12. So again, this is just all review. So b can be 16, or b can be negative 4. But if you plug in negative 4 up here, obviously you get a negative in the logarithm, so that's not allowed. If you plug in 16 into either of the logarithms, you get a positive in the logarithm, so that's going to be the solution. And b is not equal to negative 4. That's an extraneous solution. Now, if you had some trouble factoring this, that's okay. That was kind of a more challenging problem, because 16 times 4 is not something that most students have memorized. All right, if you got that answer, good job. If you didn't get that answer, that's okay. Just go back and figure out what you did wrong. So let's do some more of these types of problems. We're going to use logarithm property 5 again to combine the logarithms. And again, you probably want to use brackets when you're doing this. But now we're actually going to multiply two binomials. When you do this, remember you have to use something called FOIL. F-O-I-L. That tells us to multiply the first terms. X times x is x squared. Outside terms, x times 3 is 3x. Inside terms, negative 2 times x is negative 2x. And the last terms, negative 2 times 3, negative 2 times 3 is negative 6. So again, that's FOIL. This is all review. All right, now we can combine the inner terms. 3x minus 2x is x. And I want you to understand very clearly that you don't have to show that intermediate step. You can go straight from here to here if you want to. I'm just showing every step to make sure that we know what's going on. Okay, so we've pretty much simplified as much as we possibly can. I'm going to put a note here. We used FOIL. So now we're going to convert to an exponential equation. Remember, the base is that little number 6 next to the logarithm, and the exponent is whatever the logarithm is equal to. And whatever's in the log function goes on the other side. 6 to the second power is 36. And we need to recognize this as a quadratic equation and put it in standard form. If we don't recognize it as a quadratic and we don't put it in standard form, then there's no way that we can solve it, because quadratic equations require special methods to solve. We're going to use factoring, because it just so happens that this equation is factorable. We're going to use x and x because it's x squared, and what two numbers multiply to negative 42 and add up to positive 1? What are two numbers that multiply to negative 42 and add up to positive 1? If you said 7 and negative 6, you're correct. So changing that expression to that product of binomials tells us that x can be negative 7 or x can be positive 6. Now, we need to check for extraneous solutions. If you plug in the negative 7, then you see we have negatives in both of these logarithms. A negative here in blue and a negative here in blue. So negative 7 is obviously an extraneous solution, so we say not equal to negative 7. Now if we plug in 6, we get a positive here, and we also get a positive here. So 6 is going to be one of our solutions. Alright, so I want you to try number 6. You can use number 5 to help you. And when you come back, we'll do it together. Alright, we're back. I'm going to use, obviously, logarithm property 5 to combine those logarithms. And we're going to use FOIL, of course, because we're multiplying binomials. So remember that acronym FOIL. First terms, x times x is x squared. Outside terms, x times negative 6 is negative 6x. Negative 4 times x, that's the I term, that's negative 4x. And the last terms, L, that's negative 4 times negative 6 is positive 24. Now again, you can do a lot of this math in your head and just simplify those inner terms. But I want to show every step, just so you can get some good review of this basic math, basic algebra. So now we're going to simplify the inner terms, and we have x squared minus 10x plus 24. And now we have nothing left to do. We cannot simplify this logarithmic equation any further. So let's convert to an exponential equation. And we're going to have to use exponent rule 6, which tells us anything raised to the first power, just whatever that number is. And again, it's so important to recognize this as a quadratic equation, and to know that we cannot solve the quadratic unless we convert to standard form by subtracting 3 from both sides. And now we're going to solve by factoring. What two numbers multiply to 21 and add up to negative 10? What are two numbers that multiply together to get 21 and they add together to get negative 10? Well, that's going to be negative 7 and negative 3. So changing to that form tells us that one solution could be 7 and the other solution could be 3. Now let's plug these numbers in. If you plug in 7, you get positives in both these logarithms. But if you plug in 3, you get negatives in both these logarithms. So that's not allowed. So 3 is an extraneous solution, and x is the only actual solution. So if you got that answer, good job. All right, let's try another problem here. So this is just another type of problem that you'll see. I don't know why it keeps bumping me around like that. The program has some glitches in it. But in this problem, the logarithm is already isolated, so this is actually going to be a much easier problem. We're going to go ahead and just convert to an exponential equation. So the base is that little number next to the log. The exponent is whatever the logarithm is equal to. And whatever's in the log function, that goes on the other side. Now we're going to have to use exponent rule 6 again to say that any number raised to the first power is just whatever the number is. And we need to recognize this as a quadratic and convert it to standard form. So we're going to subtract 7 from both sides, and we get 16. And it turns out that that's a factorable quadratic expression. So what two numbers multiply to 16 and add up to 10? What are two numbers that multiply to 16 and add up to 10? Well, if you said 8 and 2, you're correct. So one solution could be negative 8, and the other solution could be negative 2. But we have to check these solutions to make sure that they don't produce a negative inside this this blue part here. It's a little tedious to have to check these solutions, but it's just something we have to do. So let's plug in negative 2 and plug it in here also. So negative 2 squared is 4. 10 times negative 2 is negative 20. 4 minus 20 is negative 16. Negative 16 plus 23 is 7, so that works. If you plug in negative 8 squared is 64. Negative 8 times 10 is negative 80. 64 minus 80 is negative 16, plus 23 is 7. So that works also. We didn't get a negative inside this this logarithm. All right, so those are both solutions. And now I want you to try number 8, and when you come back, we'll do it together. All right, we're back. We don't really have to isolate the logarithm because it's already isolated, so we'll just convert to an exponential equation, and we're going to have to use exponent rule number 6 Anything raised to the first power is just whatever that number is. And now we need to recognize this equation as a quadratic equation and put it in standard form. Subtract 2 from both sides. And now we're going to factor what two numbers multiply to 2 and add up to -3. That's going to be -1 and -2. And that tells us that one solution could be 1, and the other solution could be 2, but we need to check those. If you plug in 1, we have 1 squared, and then -3 times 1 is -3, so we have 1 minus 3 is -2, -2 plus 4 is +2, so we get a positive. And if you plug in 2 here, notice we're going to get the same number. 2 squared is 4, -3 times 2 is -6, 4 minus 6 is -2, -2 plus 4 is 2. So we get a positive in both examples. So x can be 1 or 2. If you got those answers, good job. Alright, let's go on to number 9. Now we're going to solve expressions of the form ax squared plus bx plus c. What that means is we're going to have a coefficient in front of the x squared term. Remember, that complicates things. We can't simply ask what two numbers multiply to this number and add up to this number. They are going to multiply to this number, but they're not going to add up to this number because we're going to have a coefficient there, you see. So it complicates things. So let's try number 9. The logarithm is already isolated, so we can just go ahead and convert to an exponential equation. And 4 squared is 16. And we're going to subtract 16 from both sides. And we get 20 on the right side. And it turns out that this quadratic expression is factorable, but it's more difficult to factor it than the previous expressions. Why? Because we have a coefficient on the x squared term. So first thing we need to do is ask what two numbers multiply to 2. Well, obviously that's just 2 and 1. So we write 2x and x, because 2x times x is 2x squared. Now we ask what two numbers multiply to 20. Well, there's 3 options: 1 times 20, 2 times 10, and 4 times 5. So I'm going to use 4 times 5. We know they both have to be negative because they multiply to a positive and add up to a negative. And at this point, we have to check to make sure that this works. We have to FOIL. So f of FOIL is 2x times x. That's 2x squared. And O of FOIL, outside terms, 2x times -5. That's -10x. And inside terms, -4 times x is -4x. And last terms, -4 times -5 is +20. Again, that's FOIL, the acronym FOIL. This is all review. We've done this many times in this class. So now -10x minus 4x, that's -14x. So it didn't work. We don't want -14x, we want -13x. So what do? Well, let's try switching the 5 and the 4. Let's put the 4 over here and the 5 here. Now let's try it again. Now please be aware that you don't have to multiply the first terms and the last terms, because we know that those are going to work. We already designed it that way. So you only have to multiply the outside terms. 2x times -4 is -x, and -5 times x is -5x. Combine those and you get -13x. So now we're in business. We know that this is the proper factorization of this green term up here, or green expression. So now it's still more complicated, because we know that if we plug in +4, we get a 0 here. But what do we plug in here? That looks like that's going to be some kind of a fraction. A lot of students would say, well, we just plug in 5. Well, no, because there's a coefficient there. So what do we plug in to make that factor 0? Again, we have to make it 0, so when we multiply by this number, we get 0. We want to make the equation work. Well, we just set 2x minus 5 equal to 0 and add 5 to both sides, divide by 2, and we get 5/2. So those are the two possible solutions. So if we plug in 4, because we want to check for extraneous solutions, so 4 times 4 is 16, 16 times 2 is 32, negative 13 times 4 is negative 52, 32 minus 52 is negative 20, negative 20 plus 36 is 16, and we have a positive inside that logarithm. If you plug in 5/2, you get the same thing. You get positive 16, but that's going to be kind of tedious. Now what you can do is just use your calculator in that case, because plugging in 5/2 is going to be kind of tedious. So let's do that. Let's enter 5 divided by 2, and then we're going to square that, push x squared at the upper left, and then times 2 equals, and then minus 13 times our number, which was 2.5, equals, and then plus 36, and you see we get a positive number. So sometimes you can use your calculator if the arithmetic is going to get kind of tedious. So both of those numbers work. And let's try one more of these before you try one on your own. Again, we're factoring expressions that have a coefficient on that x squared term. So we have to combine these logarithms using logarithm property 5. And remember, when you have multiple sets of parentheses, it's probably good to use brackets to avoid confusion. And now we're going to use the distributed property. 6x times x is 6x squared, and 6x times 25 over 6 is 25x. Now some students might have some trouble with that, but the 6's, they just cancel out when you multiply. But remember, when you're multiplying a fraction by something that looks like a whole number, you just write the number over 1, and then you multiply straight across. But remember, when you're multiplying fractions and there's a number on the top and the bottom that's the same, you just cancel those out. Now you're probably wondering, well, couldn't we just multiply 6x times 25? And that is correct. You'd end up with 150x, and then 6 times 1 is 6, but then you just have to reduce, and you'd end up with the 6 is canceling out anyway. So again, that's all review. So now we've simplified the logarithmic equation as much as we can, and we're going to convert to an exponential equation. 5 squared is 25. And we have a quadratic equation, so we're going to convert to standard form by subtracting 25 from both sides. And again, the problem is this coefficient. You see, we cannot ask what two numbers multiply to negative 25 and add up to 25. The numbers are going to multiply to negative 25, but they're not going to add up to 25 because we have this coefficient here that complicates things. So what we first have to ask is what two numbers multiply to 6. It could be 6 and 1, or it could be 2 and 3. I'm going to try 2 and 3. And what two numbers multiply to negative 25? There's only two options, 1 times 25 and 5 times 5. I'm going to try 5 times 5. Obviously one has to be positive, the other has to be negative. And now we need to FOIL this out. But again, you don't have to do the F and the L terms of FOIL, because we already designed those blue terms. Or we already designed this factorization so the blue terms would work out. You only have to use, or you only have to check the O and the I terms. So outside terms, 2x times 5 is 10x. And I terms, negative 5 times 3x is negative 15x. 10x minus 15x is negative 5x. Did we get the right yellow number? No, we did not. That's okay. I think the answer is going to be, instead of 2x and 3x, I think it's going to be 6x and x. So let's try that, because there's not really many options when it comes to 25. So again, we only have to check the O and the I terms. So 6x times 5 is 30x, and negative 5 times x is negative 5x. Subtract and you get 25x. So it looks like that's the proper factorization. Guess I didn't need that 0. So x can obviously be equal to negative 5, because you plug in negative 5, you get a 0 here. But for the other expression, we're going to need to set that equal to 0. It's a little more complicated. And then we're going to have to solve for x. Add 5 to both sides, divide both sides by 6, and we get 5/6. Actually, I shouldn't rectangle that yet, because we don't know if that's an answer. Again, we want to know what numbers do you plug in here to make this 0. It's going to be a fraction, 5/6. Alright, so if we plug in negative 5 up here, you can see immediately we're going to have a negative in the logarithm. So that's an extraneous solution. So let's write not equal to. And what if we plug in 5/6? Well, if we plug in 5/6 here, we get a positive. And if we plug it in here, we get a positive. So 5/6, it looks like that's going to be a solution. So again, the difference with these problems is that we have coefficients on these quadratic expressions. You see the yellow 2 and the yellow 6, we have coefficients on those x squared terms, so it makes it more difficult to factor. So I want you to go ahead and take a screenshot of number 9 and 10, or a picture with your phone, and those are going to help you to solve number 11. So go ahead and try number 11, and when you come back, we'll do it together. Alright, we're back. The logarithm is already isolated, so we can go ahead and just convert to an exponential equation. And we're going to need to use exponent rule 7, which tells us any number raised to the 0 power is just 1. And now we see we have a quadratic equation, but it's not in standard form. So in order to solve it, we have to subtract 1 from both sides. And now we're going to factor, but remember, when you have a coefficient on the x squared term, the first thing you have to ask is what two numbers multiply to 5, and that's going to be 5 and 1. And what two numbers multiply to 1? That's just going to be 1 and 1, and I think that's really the only option. So let's just check to make sure. Again, you don't have to use the F and the L of FOIL, only the O and the I of FOIL. So 5x times 1, that's outside terms. 1 times x, that's the inside terms. And add those up, you get 6x. So that's what we want, 6x up here. So if we plug in negative 1 to this expression, we see that makes 0. And what do we plug into x to make that expression a 0 up there? Well, we're going to have to solve this equation, subtract 1 from both sides, divide both sides by 5, and we get negative 1/5. We can't rectangle that yet. We need to check. With these particular problems, you're always going to get a positive number, but we can check that. Negative 1 squared is 1, 1 times 5 is 5, 6 times negative 1 is negative 6, add 2, and you get 1. So that's a positive. If you plug in negative 1/5, you're also going to get 1. But again, you can use your calculator just to be sure. So let's open our calculator. So 1 divided by 5 equals, and it's negative, so I'm going to push the plus minus button down at the left. And then we're going to square that, upper left, x squared, and then times 5 equals, and then plus 6 times 0.2, that was our x value, and then change it to a negative, equals, and then plus 2 equals, so it's 1. So we have a positive number in the blue here, and that means that negative 1/5 is a solution also. So we have negative 1/5 and negative 1. If you got those answers, good job. So why don't you go ahead and try number 12. Again, you can use numbers 9 and 10 to help you, and also number 11. When you come back, we'll do it together. All right, we're back. So we're going to need to use logarithm property 5 to combine those logarithms. And we're going to use the distributive property. 3x times x is 3x squared. 3x times 1/3 is x. Again, when you multiply something that looks like a whole number by a fraction, we just write that number over 1 and multiply straight across, and we get 3x over 3, which reduces to x because the 3's just cancel out. Most teachers are not going to show you that, but I'm just trying to be thorough here. Because this is intermediate algebra. At this level, teachers are just going to expect you to know that. So now we're going to convert. That little number next to the log is the base. Whatever the logarithm is equal to is the exponent. And whatever's in the log function goes on the other side. We're going to need to use exponent rule 6. It tells us any number raised to the first power is just whatever that number is. And we have to recognize this as a quadratic equation and put it in standard form by subtracting 2 from both sides. And again, this coefficient here complicates things. That means that we have to first ask what two numbers multiply to 3. Obviously that's 3 and 1. And then we ask what two numbers multiply to negative 2. So that's going to be, let's try negative 2 and positive 1. Now we're going to check using FOIL, but remember you don't have to use the F and the L terms of FOIL because we set it up that way to where it would work. So we just need to use O. 3x times 1 is 3x, and the I term, negative 2 times x, is negative 2x. Subtract, and you get positive 1x. We don't want positive 1x, we want negative 1x, but that's okay. If you get the right number but the wrong sign, then we just have to flip these signs. Change from negative 2 to positive 2 and from positive 1 to negative 1. Alright, so we can tell that x can be 1. That'll make this factor 0. But we're not quite sure what's going to make the other factor 0, so we're going to have to write an equation, subtract 2 from both sides, divide both sides by 3, and we get negative 2/3. And we don't know if that's an answer yet. So if we plug in negative 2/3, immediately we know that that's going to be a negative inside the logarithm. So that's an extraneous solution. So we write not equal to. If we plug in 1 here, that doesn't produce a negative, so that's okay. If we plug in 1 here, 1 minus 1/3 is 2/3, so that's still a positive. If you got the right answers on those, good job. Alright, so now we're going to go to equations where we have to, again, solve a quadratic equation, but with these equations, we're not going to be able to factor the expressions. We're going to have to use the quadratic formula. So again, we're reviewing logarithms, but at the same time, we're reviewing how to solve quadratic equations. So let's use logarithm property 5 as usual to combine these logarithms, and we're going to use the distributed property. X times x is x squared, x times negative 2 is negative 2x, and now we're going to convert to an exponential equation. Anything raised to the first power, that's just whatever that number is. That's exponent rule 6. And now we have to recognize this as a quadratic equation and put it in standard form. By subtracting 5 from both sides. And now, what two numbers multiply to negative 5 and add up to negative 2? What are two numbers that multiply to negative 5 and they add up to negative 2? Well, the answer is there are no simple numbers that fit that description. This expression is not easily factorable. So we're going to have to use the quadratic formula. So let's erase these parentheses and let's see if we can remember our formula. The formula is negative b plus or minus root b squared minus 4ac all over 2a. And in this case, b is going to be, well, let's write a first. A is 1. And b is negative 2. And c is negative 5. So again, this is all review, but in case you don't remember how this works, we're writing this all out. So now we're going to plug in b. So we have negative b plus or minus root b squared minus 4 times a times c all over 2 times a. Now again, just so you know which number is which, that's c, that yellow c, and we have b plugged in twice, and we have a plugged in twice. Again, this is just all review from what we did in previous classes in this course. You don't have to use colors and all this. I just want to be clear what's going on here. So now, a double negative, that just becomes positive. So we have positive 2 plus or minus root negative 2 squared is 4. Negative 4 times 1 is negative 4. Negative 4 times negative 5 is positive 20. And 2 times 1 is 2. And 4 plus 20 is 24. And at this point, we're out of room, but that's okay, because we can just use an arrow to go up here, and we have plenty of room. So root 24, remember we can factor 24 to 4 times 6, and the 4 comes out as a 2, and the 6 stays in. So we have 2 plus or minus 2 root 6 all over 2 is equal to x. Now, if you don't remember how to change root 24 to 2 root 6, you can go back to my class on roots. We have multiple classes on roots in this course. Remember, if you have root 24, you can factor to 4 times 6, and then, you can factor to 4 times 6, and then you can break up into 2 roots. Root 4 times root 6, and root 4 is 2, and just get rid of the dot, and you're left with 2 root 6. Those are all principles that we learned. So now, if you're dividing a polynomial by a monomial, you just divide each term. So 2 divided by 2 is 1, and 2 root 6 divided by 2 is root 6. So we have 2 possible solutions. X could be 1 plus root 6, or x could be 1 minus root 6. Alright, so now we have to check for extraneous solutions. Now, it's very important to think about the logic of this. We could just use a calculator to figure out exactly what these numbers are going to be, but we know that root 4 is 2, right? The square root of 4 is 2, so that means the square root of 6 is going to be bigger than 2. So a number bigger than 2 plus 1 is going to be at least 3. If you plug that in here, then obviously that's going to produce a positive and a positive over here. So that is definitely a solution because we didn't have a negative in the logarithm. But again, if this number is bigger than root 4, then that means 1 minus some number, that's going to give us a negative. And if you plug in a negative into this logarithm, obviously we have an extraneous solution. So 1 minus root 6 is not a solution. All right, so let's do one more of these before you try one on your own. So we're going to use logarithm property 5 as usual to combine those logarithms. And then we're going to use the distribution rule. 3x times x is 3x squared. 3x times 2 is 6x. Then we're going to convert to an exponential equation. 4 to the 0 power is equal to whatever's in the log function. Again, that little number next to the log is the base, and whatever the logarithm is equal to is the exponent. We're going to need to use exponent rule 7 to show that any number raised to the 0 power is just 1. And now we have a quadratic equation. But we can't solve it unless we put it in standard form. So we're going to subtract 1 from both sides. Now it's in standard form, but we have a coefficient here, so we're going to have to ask what two numbers multiply to 3, and that's obviously 3x and 1, and then what two numbers multiply to negative 1, well that's negative 1 and positive 1. But if you FOIL this out, you're not going to get a 6 in the inner term. It doesn't matter what you do, you're not going to get a 6. So this expression is not factorable. At least it's not easily factorable. So we're going to have to use the quadratic formula. So let's write the tool that we're using. x is equal to negative b plus or minus root b squared minus 4ac all over 2a, and a in this case is equal to 3, b is equal to 6, and c is equal to negative 1. So you don't have to use colors, but I'm just doing this to help you. So now we're going to plug in. B is 6. And A is 3. And C is negative 1. And again, A is 3. So we plugged in A twice. We plugged in B twice. And we plugged in C once. Okay, so all we have to do is simplify this equation now. 6 squared is 36. Negative 4 times 3 is negative 12. Negative 12 times negative 1 is positive 12. 2 times 3 is 6. 36 plus 12 is 48. And we're out of room, but that's okay. We can use an arrow to move up. And 48 is 16 times 3, so the 16 is a perfect square. That comes out as a 4. And the 3 stays inside. So this purple root 48 became 4 root 3. Okay, so we're going to reduce this fraction because 2 goes into all those numbers. If we divide the bottom, remember the fundamental principle of fractions tells you you can divide both sides of a fraction by the same number, and it remains the same value. So 6 divided by 2 is 3, and when you divide a polynomial by a monomial, you just divide each term. So negative 6 divided by 2 is 3, and 4 root 3 divided by 2 is 2 root 3. So that means we have 2 possible solutions. One is negative 3 plus 2 root 3 over 3, and the other is negative 3 minus 2 root 3 over 3. So we're going to have to check both those solutions. Now this number here in blue, that has to be a negative number because you're taking negative 3 and subtracting another a number. So if you plug in a negative number back into the original equation, you can see it's going to make a negative in the logarithm, so that's an extraneous solution. Now for this expression, it's going to be kind of hard to see if that's positive or negative. So I'm going to use my calculator. And I'm going to enter 3, then the plus minus button to change it to a negative. And I'm going to add 2 times, and then you're going to push the 3 number, and then you're going to push the square root button, and then equals. And then you're going to divide by 3, and you can see we get a positive number. So this number here is definitely positive. So if you plug in a positive number to these logarithms, we know we're going to get a positive here and a positive number here. So we're not going to have any problems with that number. So that's the solution. Alright, so I want you to try number 15. You can use number 14 to help you. And when you come back, we'll do it together. Alright, we're back. I'm going to use logarithm property 5 to combine the logarithms. And I'm going to use the distributive property. X times x is x squared. X times 5 is 5x. And then I'm going to translate to an exponential equation. 2 to the second power is 4. Now we need to recognize that we have a quadratic equation, and we need to put it in standard form or else we can't solve it. But now if we try to figure out what two numbers multiply to -4 and add up to 5, you're going to see that there really is nothing. There are no numbers that multiply to -4 and add up to 5, at least not rational numbers. So we're going to have to use the quadratic formula. So let's write that formula that we're going to use. We need to show the tool that we're using. And we need to identify A, B, and C. So A is equal to 1, B is equal to 5, and C is equal to -4. Just to be clear, we can highlight these. So let's plug in those numbers. So we have -5 plus or minus √5 squared minus 4 times A times C all over 2 times 1. So we plugged in C once, we plugged in B twice, and we plugged in A twice. So now we just have to simplify. 5 squared is 25. -4 times 1 is -4. -4 times -4 is positive 16. 2 times 1 is 2. And 25 plus 16 is 41. So now we have two solutions. One solution is -5 plus √41 over 2. And the other solution is -5 minus √41 over 2. But we have to check for extraneous solutions. This number obviously is going to be a negative because you're taking -5, subtracting a number. That's just going to give you a negative. But if you plug in a negative into this logarithm, obviously that's not allowed. So this is an extraneous solution. Now here we don't know if this is positive or negative. So we need to estimate what this root is going to be. We could use a calculator, but we know √36 is 6, because 36 is a perfect square. √36 is 6, and √41 has to be bigger than √36, than 6. So this fraction has to be positive. And if you plug in a positive here or here, obviously it's we're not going to produce a negative in the log function. So that is the solution. Alright, so if you got that answer, good job. If you got stuck in a few parts there, that's okay. You can take a screenshot or a picture with your phone of these two problems to help you with number 16. Go ahead and try number 16, and when you come back, we'll do it together. Alright, we're back. We're going to use logarithm property 5 to combine those logarithms. And then we're going to use the distribution property. 4x times x is 4x squared. 4x times negative 3 is negative 12x. And then we're going to translate to an exponential equation. The base is that little number 3. The exponent is whatever the logarithm is equal to. And what's in the log function goes on the other side. We're going to have to use the exponent rule 7. Anything raised to the 0 power is just 1. And we now have to recognize this as a quadratic equation and also understand that if we don't convert to standard form by putting everything on one side, then we're not going to be able to solve it. So we subtracted 1 from both sides. And now you could try to factor and ask what two numbers multiply to 4x squared. Could be 2x and 2x or 4x and x. And then ask what two numbers multiply to negative 1. Could be, well, the only option is negative 1 and positive 1. But if you try to factor, you're going to find that there's nothing that works. It just doesn't work. And so this expression is not easily factorable. So we're going to have to use the quadratic formula. A is going to be 4, B is going to be negative 12, and C is going to be negative 1. X is equal to negative b plus or minus, and again this is the quadratic formula. Square root b squared minus 4ac all over 2 times a. Again, you don't have to color these, but I'm just showing you exactly where these numbers are going to be coming from. So we have negative b plus or minus root b squared minus 4 times a times c all over 2 times a. So we plugged in a twice, we plugged in b twice, and we plugged in c once. Alright, so now we just have to simplify that expression. A double negative becomes a positive, so that's positive 12. Negative 12 squared is 144. Negative 4 times 4 is negative 16. Negative 16 times negative 1 is positive 16. 2 times 4 is 8. 144 plus 16 is 160. And we're out of room, but that's okay. We can just go up here. Now 160 is 16 times 10. 16 comes out as a perfect square, the 10 stays in. And so again, that root 160, that became 4 root 10. You can go back to my class on roots to review that. We had root 160, we changed it to root 16 times 10, and we used that principle where you can break up into 2 roots, and root 16 is 4, and then just get rid of the dot. Okay, now we're just going to reduce that fraction. So remember, you can reduce a fraction by dividing both sides by the same number. So we're going to divide both sides by 4, So 8 divided by 4 is 2. And remember, when you divide a polynomial by a monomial, you just divide each term. So 12 divided by 4 is 3. And 4 root 10 divided by 4 is root 10. So that tells us that there are two possible solutions. One solution could be 3 plus root 10 over 2. And the other solution could be 3 minus root 10 over 2. Now, to check for extraneous solutions, you could use a calculator to figure out roughly what these values would be, but remember, sometimes you don't really need to use a calculator. We don't know what root 10 is, but we do know root 9 is 3. So if root 9 is 3, that means root 10 would be slightly bigger than 3. So if you subtract a number slightly bigger than 3 from 3, well, you're going to get a negative. So this fraction is going to be a negative. And obviously, if you plug in a negative here, that's going to give you a negative number inside the logarithm. So we know that 3 minus root 10 over 2 is an extraneous solution. Now, this is obviously a positive number, but we need to figure out if it's going to produce a negative when we subtract it, or subtract 3 from it. Now, again, root 10 is very close to root 9. Root 9 is 3. So if we pretend that this is root 9, that would be 3 plus 3 is 6, and then divided by 2 is 3. If you subtract 3 from 3, you get 0, and that doesn't really work either. You can't have 0 in a logarithm. So we're going to have to use some logic here. Again, root 10 is going to be slightly bigger than root 9. So that means when you add to 3 and divide by 2, you're going to get a number that's slightly bigger than 3. So when you subtract 3, you're still going to get a positive number, and you're not going to get 0 either. So this is going to be our answer. Alright, so if you got that answer, good job. So we're going to do a few more problems. In these problems, notice that we have a variable in the base, and we actually have a binomial in the base. But we're going to solve these equations in the same way we did in the previous problems. The logarithm is already isolated, so we can go ahead and translate to an exponential equation. The base is that little expression there next to the logarithm, and the exponent is whatever the logarithm is equal to, and whatever's in the log function, that goes on the other side of the equation. Now at this point, we need to expand this expression. If we didn't have an x here, then we could just keep this expression in the factored form and then square root. But the problem is we have this x here, and the only way to solve this problem is to go ahead and expand this expression. So remember, x plus 1 to the second power, that just means x plus 1 times x plus 1. So now we're multiplying two binomials, a binomial in blue and a binomial in green. When you do that, you have to use FOIL. F-O-I-L. First terms, x times x is x squared. Outside terms, x times 1 is 1x. Inside terms, 1 times x is 1x. And last terms, 1 times 1 is 1. You don't have to show that intermediate step. You can just go right to the next step and combine the inner terms. X plus x is 2x. So now, believe it or not, you have a quadratic equation. It doesn't look like a quadratic equation because it's not in standard form. Now notice that the x squared term is on the left side of the equation. On all the problems we did previously, the x squared term was on the right side of the equation. But we're just going to leave it over here because if we put it on the right side of the equation, then we'd end up with a negative coefficient. We don't want that. We want it to stay positive. So we're going to put everything on the left side of the equation instead of the right side. So I'm going to add 2x to both sides and subtract 46 from both sides. And now we have a standard form equation with a positive x squared coefficient. And in the previous problems that we did over here, we could not factor. We had to use the quadratic formula. You see this red rectangle, the quadratic formula. But this expression can be factored. So what two numbers multiply to negative 45 and add up to positive 4? Two numbers that multiply to negative 45 and add up to positive 44. Well, that's going to be positive 9 and negative 5. So that tells us that one solution can possibly be negative 9 and the other solution can be possibly 5. All right, so we need to check our answers. Immediately I see a problem with negative 9. Remember, you can't have a negative in the logarithm, but you also cannot have a negative in the base of a logarithm. If you plug in negative 9 into that base, you're going to get negative 8. So that's an extraneous solution. So we can say not equal to 9. Now if you plug in 5, you get a positive base here, so that's okay. And if you plug in 5 here, we also get a positive number. So that's going to be the solution, x equals 5. Alright, so I'm going to move this up a little bit just to give us some more room. And let's try one more of those. Before you try one on your own, I want to put a divider. So the logarithm is already isolated. So I'm just going to convert to an exponential equation. The base is that little number there. And the exponent is whatever the logarithm is equal to, which is 1. And whatever's in the log function, that goes on the other side of the equation. Now anything raised to the 1 power is just whatever that number is. That's exponent rule 6. So that just becomes x minus 3. And so now, believe it or not, we have a quadratic equation, but it certainly doesn't look like a quadratic equation, right? We have to get it in standard form. Now notice the x squared over here is a positive x squared, and we want to keep it positive x squared. So we're going to put everything on the right side of the equation. We're going to subtract, actually we're going to add 3 to both sides, so we get 36. And we're going to subtract x from both sides to get negative 12x. But we still don't have standard form. This is not in standard form. All right. The reason is it's backwards. We need the x squared to go first, and then the x term, and then the number that does not have an x. All right. So now we're in standard form. Turns out this can be factored. What two numbers multiply to 36 and add up to negative 12? What are two numbers that multiply to 36 and add up to negative 12? Well, that's going to be negative 6 and negative 6. So that tells us one answer is 6, and the other answer is, well, exact same thing, 6. You don't have to write it twice. If you plug in 6 here, we get a positive. We just need to know if you get a positive plugging it in here. So 6 times 6 is 36. Negative 11 times 6 is negative 66. So negative 66 plus 36 is negative 30, and negative 30 plus 33 is 3. So we have a positive number. So it looks like that's going to work. So we can just erase one of those and say x is equal to 6. Alright, so I want you to try some of those problems. Go ahead and try number 19, and when you come back, we'll do it together. Alright, we're back. So we're going to translate into an exponential equation. And we're going to have to expand the left side of the equation. And to do that, because we're multiplying binomials, we're going to have to use FOIL. Multiply the first terms, then the outside terms, then the inside terms, and the last terms. X times x is x squared, x times negative 5 is negative 5x, negative 5 times x is negative 5x, negative 5 times negative 5 is 25. And believe it or not, this is a quadratic equation. But it doesn't look like a quadratic equation because it's not in standard form. So then I'm going to combine the negative 5x's to get negative 10x. And notice I have a 2x squared over here. If I try to put that 2x squared on the left side of the equation, then it's going to produce a negative coefficient on the x squared term. So I want to keep a positive coefficient on the x squared term, so I'm going to put everything on the right side of the equation. So 2x squared minus x squared is x squared, subtracting x squared from both sides. And then we're going to add 10x to both sides. That'll give us 7x, and subtract 25 from both sides, and we get negative 8. We can factor that expression. What two numbers multiply to negative 8 and add up to 7? That's going to be 8 and negative 1. So one possible solution is negative 8, and the other possible solution is 1. But we have to check to make sure we don't have extraneous solutions. If you plug in negative 8 here, we have a negative in the base. So obviously we can tell immediately that there's that's an extraneous solution. Turns out that if you plug in 1 here, you also get a negative number. So what that means is they're both extraneous. So that was kind of a trick problem. So I didn't mean to give you a trick problem there, but both those answers are extraneous. Alright, let's do number 20. Attempt number 20, and when you come back, we'll do it together. Alright, we're back. So the logarithm is already isolated, so we're going to translate to an exponential equation. The base is that little expression there next to the logarithm. The exponent is whatever the logarithm is equal to, and whatever's inside the log function, that goes on the other side of the equation. Anything raised to the first power, that's just going to be whatever that number is. That's exponent rule 6. And so we have 4x minus 9 is equal to x squared plus 2x minus 12. Believe it or not, that's a quadratic equation. And we're going to have to put it in standard form in order to solve. I want to keep a positive coefficient on the x squared term. So I'm going to put everything on the right side of the equation. I'm going to subtract 4x from both sides and add 9 to both sides, and then we get an expression that's easily factorable. What two numbers multiply to negative 3 and add up to negative 2? That's going to be negative 3 and positive 1. So that means that one solution could be 3 and another solution could be negative 1. But we have to check. If you plug in negative 1 here, then you can see that's going to produce a negative base. So that's not going to work. So that's an extraneous solution. And if you plug in 3, you get a positive base here. We just have to make sure we get a positive number here. So 3 squared is 9. 2 times 3 is 6, and then minus 12. So that's 15 minus 12 is 3, so that works. So x is a solution. If you got that answer, good job. Alright, that's the class today, so let's take screenshots of all the work we did to help you with your homework or to study for tests. This is screenshot number 1 and screenshot number 2 and number 3 and number 4 and number 5 and number 6. And don't go before we get your homework. Just take a look at the homework. Here's your homework. Go ahead and get a screenshot of that. And remember, if you don't do that homework, it's a 100% guarantee you're going to learn absolutely nothing in this entire course. So get that homework done, and I'll look forward to seeing you in the next class.